Good afternoon, everyone. On behalf of all of us at the National Glass Association, thank you for making time in your day to join us for the year's final installment of Thirsty Thursday. Before we dive into today's topic, a few NGA updates for you. On the next slide, you'll see that registration is open for the NGA Glass Conference, taking place January 24th to the 26th in Long Beach, California. Early bird registration rates are in effect until December 13th, so don't delay. That gives you about a week yet to register at our discounted rate, and we hope to see you there. On the next slide, you'll see NGA is excited to share we've added a second design guide to our publications library, this one dedicated to frameless shower enclosures. The new design guide is a 15-page document dedicated to the design considerations, tolerances, hardware, and maintenance guidelines. But this is just the beginning. We have a team assembling now to develop a new installation guide to complement it. So if you're interested in participating on this new task group, please send any NGA staff person an email or feel free to drop a note in this Zoom chat to let us know. And we're going back to Nashville in March for the 24th annual BEC conference and are excited to use this opportunity to co-locate with GPAD, Glass Processing Automation Days. There will be independent programming targeted to the unique audiences of each event, plus special programming on March 29th to bridge the supply chain. When you make your travel plans, you'll want to make sure to stay for the programming into the afternoon on the 29th. And we still have some great sponsorship packages available, so you can contact me if you'd like to learn more. As we begin the presentation, please use the chat feature in your Zoom toolbar to submit questions at any time during the presentation, and we'll address as many as we can at the end. I'm now pleased to introduce our speaker, Julia Schimmelpenningh. Julia is the Architectural Technical Engagement Manager for Eastman. She has 30+ years experience in laminated glass and supported glass fabricators, architects, designers, engineers, and specifiers. Her work includes new product qualification and commercialization, regulatory development, and industry support for laminated glazing solutions. Julia also manages the Americas Customer Support Laboratories in the US and Brazil. Being very active in the glazing industry, she currently serves as the ASTM EO6 chair and is on the board of directors for ASTM International. Julie, welcome.
Well, thank you, Sarah. Hopefully you can hear me okay.
Yes, sounds good.
All right, great. Well, and welcome to everyone that took some time on a busy holiday season to come and learn a little bit about one of the most exciting things in the world is standards for laminated glass. I'm very pleased to be here and very thankful that NGA asked me to try to provide an update for you on these standards. As you know, this session is 30 minutes long. So what we're going to do is we're going to only hit on the new standards that have been published over the last probably 14 to 16 months. And certainly we can answer questions on other standards and whatnot, but I did want to bring the newest ones to your attention today. So our agenda will be to just look and review what the objective of the standards are, look at the new ASTM standards for laminated glass, and then go over a summary of what it is, and then hopefully answer as many questions as you may have as we go through those. So with that, we're going to look at the objectives for standards. What we're looking to do is to create documents that are needed for guidance in the various industries that the standards are written for. Standards are written to enable fair product comparisons and classifications. Standards are written for performance, but not around products. So although there may be a product need to develop a standard, the standard itself must evolve past that initial need to provide an overall and a consensus document. They do get refined with market pace, and that's what you'll see with these new standards that we'll be talking about today. So as the needs of the industry change, the standards will likely be updated to help reflect those needs as much as the data allows. You update them for clarification. Many times these standards are test standards. Various labs will have equipment or new employees or a change in how the materials are supplied, and the clarification to the standard is needed. And a lot of times that's how you'll see a standard update. But mostly they're there to facilitate equality. That means that we have methods of tests, we have design methodologies and calculations so that everyone is looking at things the same way. And we also are trying to provide the information so consumer and end users can make fair and level comparisons. And so with those objectives in mind, we are going to dive into what we have for new standards for laminated glass. Now, as you all know, there are several standards for glass and glazing and laminated glass in general that have been published and have been serving the industry very well for many, many years. So one of the things that we want to look at is why were these new standards needed? And it's always a question. Some say, hey, don't add the complexity. We're okay where we are. Others say, look, the industry is evolving. We need a little bit of guidance and some field posts as to how to go about talking about these products and comparing performances. And so we will look at why these particular standards were needed. Where did they come from? Obviously, they don't grow out of the ground. It comes from some type of documentation at some point. And then we'll also look at how will they be used. So how they'll be used, we'll get into at each of the stages. But where did they come from is one of the things that I do want to answer. And the ones that we will be talking about, at least the first two, they have come out of a need for the harmonization that occurred with ANSI Z97.1, which is the safety glazing standard for safety glazing, tempered glass, laminated glass, chemically strengthened glass, etc., that is used and referenced in the US by itself or through the CPSC, the Consumer Product Safety Commission. There is a big section within that standard that covers a lot of documentation. And the committee did think that it would be best if those items were pushed to a larger forum and that they were approved by the industry as a whole versus the smaller committee, which is ANSI Z97. And so you'll see that as we go through that they do stem from that standard, and those ones that do that should not be shocking to anyone because they have essentially been around for a while. But why were they needed? 2 out of the 3 standards we're going to talk about, they were needed just for the reason I just told you, in that we essentially wanted to have a larger group look at them, have a more consensus document, and also have an internationally referenced document. And so that's why we moved to ASTM. The third one, which is more of a quality and specification standard that we'll get to, that's needed because of all of the new applications or extended applications that laminated glass is seeing, and it has to do with adhesion. So we will address these 3 questions throughout the remainder of as we look through these standards. So the first series of standards that we want to look at are the durability and process standards. You can see that there is a listing here of 6 boxes. The first one is the weathering box, which we have currently looked at from ANSI Z97.1, and that looks at polymer degradation both indoor and outdoor. The second one is one of the new standards. You can see by the checkbox that that's the one that we will be talking about, is the ASTM standard C1900. This was published in 2020, and it is the weathering standard for polymer degradation, indoor and outdoor levels, that was extracted from the ANSI standard and created in the ASTM international format. The D1435 standard has been published for quite some time, is actually probably up for a renewal, and that is the natural outdoor weathering standard. That is referenced in the above 2. It is the methodology that tells you how to do the testing in an outdoor environment. G155 is also a long-standing standard for materials that teaches you or guides you in how to do accelerated xenon weathering for products, and that is also referenced in the ANSI and ASTM standard. And then the other standards that are out there, there's a compatibility standard that is an NGA test method. It is for sealants, and it looks at UV and moisture cyclical exposure. That has been NGA standard now for several years and is moving towards this same type of consensus in ASTM. And then the last one, another one that we'll look at a little bit more in depth, is a processing standard, which is ASTM C1914, and this discusses the bake and boil testing. Many people are familiar with this because it is a requirement of ANSI for laminated glass, but it has been broken out on its own for further discussion. So with that, the C1900, which is the weathering standard, again, it is a standard that's intended to cover the procedures for exposure of laminated glass, to look at the durability of the product and any polymer degradation. The standard itself gives you two main options to test in: an accelerated mode, which is a 3,000 hour mode, or a natural exposure mode, which is done outside in the sun. We'll talk about all of those different modes. The time duration is specified by the authority having jurisdiction. So this standard does not specify a time or a duration of exposure. However, a document like ANSI Z97 will give you the required exposure duration to meet their standard requirements. And so in this instance, ANSI Z97 says it's 3,000 hours of exposure. The evaluation for laminated glass after weathering is looking for bubbles, which is a visual assessment, looking for crazing or delamination, and all three of those are visual assessments. And then you do measurements, looking for visible light transmission decrease, looking for yellowness increase, haze increase, or a color change, which is signified by delta E. Those last four tend to be signals of some type of polymer degradation, and that's what you're looking for. Other typical extended testing that is done, which is not in the standard, is reviewing the stability of adhesion and the moisture content of the materials over time. So as we dig a little deeper, the two main types of exposures: one is natural. It is done literally outdoor on racks. You can see the types of racks with the samples that are on there. They are unbacked, meaning that the air and the environment can get to the front and the back of them. They are on an angle. They're at a 45-degree angle of exposure. And the standard does tell you that it needs to be somewhere within the 26-degree north latitude range, and that's the subtropical range, so that you get a combination of high UV, heat, and humidity. Typically, the external use products in this are things like facades, storefronts, windows, doors, and that type of stuff. You can use external exposure to clarify or to qualify things for indoor use as well. Typically, it is the same exact exposure, however, it's done under a 3mm piece of clear glass. A little bit tougher. I think that in the industry, many people revert to the accelerated for indoor exposure because of the complexity of mounting all of that on these frames. But products that would typically need indoor exposure only are things like partitions and shower doors, fins, balustrades, furniture, anything that might be located on the inside of the building. One of the keys is that natural exposure does qualify products for outdoor and indoor. And so anything that is exposed in an outdoor environment or under outdoor conditions does automatically qualify it for indoor use. These are the tables, and these are taken from ASTM C1900. There are two methods under the outdoor accelerated exposure, and you can see a typical accelerated chamber on the right. These are chambers that are operating with xenon bulbs to simulate sunlight, and the cycles are very, very prescriptive. You have a very tight and high temperature range of 145 degrees F. You have a 50% relative humidity. One has a spray and the other has no spray. And so these are the two accelerated methods. If you look at the indoor accelerated method, you'll see that it can be done in the same chamber, but not at the same time. And the reason for that is the temperature is a little bit lower. So you're at about 55 degrees or 131 instead of the 145. Your humidity is slightly higher, or sometimes you can have more humidity inside. There is no spray, and you can see the irradiance levels are slightly lower for that. And so that those are the two different indoor and outdoor applications. When you choose what a dry method over a spray method, I think the reason that the two of them are in here is currently ANSI Z97 requires the water spray. However, because of etching of the glass and the inability to get very accurate measurements, the dry method was put into ASTM as an alternative. And we can talk about how you do that as well. So what's the industry impact for the C1900 coming onto the scene? Well, the good part is there's no change in the irradiation for the accelerated weathering for ANSI Z95, and there's no change for natural exposure either. The only difference is C1900 does give you a very concise dry method, where the ANSI Z97 only currently requisitions the spray method, and you have to weather another piece of glass as a control. So that's one change. So the good news for the industry is you don't have to go and redo a whole bunch of accelerated weathering in order to comply to C1900. It standardizes weathering and reporting for materials, so it allows that comparison under the same conditions. New products have target performance criteria to meet, so it's good for the people that are creating new products as well as good for the industry to see how they compare with a very well-known set of criteria. It's compliant with SGCC requirements, and by that I mean we did not change the weathering portion of it. So as long as you follow the ANSI B method, that everything will still meet with SGCC. So again, you do not have to go and requalify anything. There may be a renewal period, and there may be some other things like that from SGCC, but the method itself is compliant. And then what we may see is increased requests for exposure data and compliance from downstream. One of the things with these standards becoming international standards is people become aware, and they may start asking additional questions and for additional backup data for that. The other part of having an international standard through ASTM is that update of the references in our standards and literature, our laminating reference guide, and all those things. Obviously, that will need to take place, and will be something we'll be talking about and working through in further NGA conferences. The next standard is ASTM C1914 that was just published this year. It is the standard method for bake and boil testing of laminated glass. Again, the great news with this is it is not a change from anything that we are used to. It is just put into a consensus standard and gives us a little bit more detail on how to run it and how to rate it. And so the purpose of this test is to measure laminate stability under a heat exposure, and also give us an assessment and can be used for quality control. You can perform this test on laminates exposed to weathering. So if you put something in an accelerated chamber or products come back from natural exposure, you can run these tests on those to see how they do. And so it can be run on weathered samples as well as samples coming off the manufacturing line. It is a visual rating after you subject the samples to heat. The heat can come in two ways. It's at 100 degrees C, 212 F. The boil is for 2 hours, and what you do is you literally submerge the laminated glass into boiling water for a 2-hour time frame, and then you take it out and rate it. Or you can put it in a 212 degree oven for 16 hours, and then you take it out and rate it. Again, what it does is it determines the stability of laminate glass to these high heat environments. It has always been referenced as the standard temperature and time in ANSI, and also for both the automotive industry and the architectural industry. Couple things that it does is it determines if there's a large amount of excess air or moisture that gets trapped in the interlayer and can cause issues. It's a good indicator of high moisture content. And it also can indicate if volatiles are formed with exposure. So say there may be some polymer degradation. You may see that you have a boil or bake failures when they come back after exposure. One thing that the boil and bake test doesn't do is it doesn't provide an indication of laminated glass being capable of impact resistance, glass shard retention, or anything like that on breakage or the edge stability. It truly is a durability test. What it looks like is it's typically run on either a 12x12 or a minimum size of a 6x6. You do 3 specimens per test. That means you would put 3 specimens from the same run or from the same laminate into the boiling water, take it out 2 hours later, or put it in the oven and take it out 16 hours later. The defects are measured from the edges or the cracks, and the defects in this case tend to be bubbles. And you can see on the right-hand side a picture of a laminate that has clearly failed this test, and you can see all of the little bubbles that are forming. One of the things that the test does allow, though, is it says you don't rate from the edge and you don't rate from cracks. And part of that reason is as you section or you cut apart to do the testing of these things, you can falsely destroy the edge. And so it gives you a leniency of about 13 millimeters to look at that. What's the impact of this standard on the industry? Again, no change to the requirements. The standards can act as a processing check for quality control and also for weathering. The same thing, new products have a criteria. A watch out is the newly approved ISO standard for laminated glass in Part 4 is not the same as this. It allows the user to decide whether they want to boil for 16 hours or bake for 2 hours or vice versa. So it does have the boil for 2, the bake for 16, but the user can choose whichever combination of those methods they want. So a caution to any of you that are specifying or looking at that is to make sure if it says it's compliant that you get what you're asking for. This also is compliant with the test method for the SGCC requirements because it follows ANSI. And we may again see requests, increased requests for production and certifications on this. Okay. So the big change in the last few minutes is the adhesion test. This is the Pummel adhesion test. Now the Pummel test has been around in the industry for decades. And this is a method to look at the relative strength of the adhesive bond between the interlayer and the glass, or inks in the glass or whatever. It is a method that is destructive. It can't be run in place. It has to be done in a laboratory. And again, it is a destructive method. So don't think you're going to do this and then go forward. So you have to have specific samples for it. You can use it to look at all different types of laminated glass. Typically 2 layers of glass is where you want to stop because then it gets a little erroneous. One of the surfaces can have anything on it, inks, coatings, fritz, patterns, whatever. You will note that because there can be some differences based on those materials and the level of adhesion. It's a qualitative test and it covers both manual and semi-automatic pummeling, and we'll show you that, but it is a visual rating. The test method is a visual rating right now. So how do you do this test? It's very rapid, and I can go through all the words of it, but we do have a video that will show it to you. So I think that will be a little bit more illustrative, but it's a rapid, systematic, really hammering of the glass. It's progressive striking. And what you're trying to do is expose the interlayer. You're trying to get the glass that easily comes off of these products to come off so you can understand the level of adhesion you have. There's a certain amount of energy necessary to pound this glass off of it and separate the 2 surfaces, the glass and the interlayer. And the strike face of the hammer needs to be as flat as possible. Otherwise, you can skew the results. And so what it's doing is determining the ratio of exposed interlayer. The higher the amount of exposed interlayer, the lower the adhesion. So what you're really trying to look for, depending on your application, is that balance of exposed interlayer and glass to give you the performance attributes you're looking for. Again, it's a relative adhesive bond. It is not an absolute. Adhesion does have a huge effect on impact resistance as well as long-term stability. There are 3 levels of grading that are in this standard, and bond strength in most applications needs to be controlled, and that is to avoid potential problems of delamination if the adhesion is too low, or sometimes post-breakage characteristics that are undesirable at high adhesion levels. And so you do really want to target it for the type of application you're looking for. Because you are smashing glass, there are some general safety guidelines, cut resistance gloves, safety goggles or glasses, and a face shield, and it does get loud. And so hearing protection is also very highly recommended. You can calibrate the material. It's a simple method. You take literally split shot, tape it to the hammer, as you can see, and you pound it, and you know that you have enough force if it flattens, and you meet the requirements for how hard it flattens. This is a great method for somebody learning how to pummel, to make sure that they have an idea on a manual pummel of how hard they have to strike the hammer. It's an excellent method for the semi-automatic because it tells you whether or not the piston is firing at the right response rate at each time. The conditioning of the pummel samples is another section that is addressed in this. The duration of how long you condition it is not specified because the thickness of the laminates and the amount of laminates you may have in your conditioning cabinet can change. So there is guidance on reaching the target temperature. You can do that with thermocouples or through experience or through calculation. The temperature options in the standard are frozen at -18°C or 0 degrees F, room temperature, or an alternate as specified by the interlayer manufacturer. The reason there's 3 different ones is because they do respond differently based on the temperatures. Okay. So after conditioning the samples, you do pummel them, and we will jump to the video so you can see exactly what that looks like, but you're systematically hitting it with a hammer, and the entire process should take less than a minute. So it's very, very quick. You do pummel systematically. So you're looking at, as you can see, the hammer hits, that's what this is showing. And you do try to go pretty deep into the sample so that you have a good body of materials to look at. You recondition the samples if they have been at other than room temperature so that all the condensation is off, and you compare the rating to pictures and rate both sides. And there's a whole bunch of information that you'll get when you get this about how to group them and how to do different things as far as the rating. But the ratings look like this. This is a rating of 0. This is not actually a rating, it is a reference. And you can see the large areas with nothing but some glass dust on the surface of the interlayer. This is a low rating, and you can see that there's about 80% free interlayer to the glass. The white parts are the glass parts that are still on. It is on a piece of cardboard, and you're actually seeing the brown cardboard below the sample. This is a medium rating, so somewhere between 20 and 80% of the interlayer is covered with glass. And then this is a high rating, meaning less than 20% of the interlayer is showing. Okay. This is a non-rating. Just quickly, this is the pummel method. This is a manual method. And you continue to do that until you reach what you have. And this is a semi-automatic method. Okay. So it's pretty quick. It's pretty easy to get through. And the interpretation of results you can see how you rate it. There's a big section on how you actually do that. But the impact of this one to the industry is the specification levels you may see based on the application needs. We may have uninformed specification where people will say, oh, I automatically always need high adhesion because that's better. Well, it's not better for all applications. Sometimes a very balanced adhesion level is best. And so understanding those differences before it gets specified is critical. The other part is you may see some requests for compliance documentation and testing, having to test coupons or batches and what the frequency is. Those questions may be coming to our laminators from the industry. Requests for Pummel standards, be it physical or pictures. Those pictures are within the ASTM standard, but some people do like physical samples. And there will be an evolution of systems and digital ratings that aren't currently available. So look for this to really start evolving. The other thing is reference to the ASTM levels, and training in laboratories is going to be very, very critical to make sure that everyone is up to speed and doing it the same way. So in summary, those are the new standards. You can see that there are ASTM standards for laminated architectural glass in all of these areas. They continue to evolve, but those were the newest ones published in the last 14 to 16 months. And the big thing is laminated specifications increase, the standards need to keep pace. The requirements for quality information on laminated glass is increasing, and the processes are developing to provide those compliance documentations from all parts of the value chain. We do have the basic standards. We have the boil and bake, we have weathering, and now we have adhesion. And there are also several additional documents that I'll call incubating within the NGA technical side and ASTM International. So we do need to watch for those. Our question, and not for today, but for at any point when we can talk to NGA, is what else is needed in the laminated market or in the glass market in general. NGA is a huge proponent of pushing these things so that we have the right standards and the right documents in place. And so please do talk to any of the NGA staff or your liaisons or your chairs about what else is needed. So I think we're a little short on time, but if there's a little time for questions, I'll be happy to answer if any came in.
Great, thank you, Julie. We do have a few questions, and we may go ahead and answer as many as we can, also just so that they're in the recording when we post it online next week, if anybody needs to reference back that. So first question, are there any long-term studies correlating the bake, boil, or other test results to the lifetime performance of laminated units?
So I think that that's a great question. The bake and boil tests tend to give you a good correlation with what we do for natural exposures. So you do see that the 2, 5, 10, whatnot years as far as bubble formation are correlated pretty well. If you don't see something in the boil and bake, you likely don't see it in the field. The trouble with that is you cannot necessarily bake every part of every laminate, and so if you have a little bit of trapped air on a corner, you may get a bubble formation in the corner, but you baked a coupon that was run the same way. So it's very similar to the heat soak test with tempered glass, for instance. You just can't do 100% inspection, but the correlation of passing the boil test and issues out in the field is very, very well documented, and it's documented with real life buildings. So that's a good thing.
Okay. This next question is asking if you have any thoughts on the fact that 6x6 or 12x12s don't replicate the real process most fabricators are using due to roller distance or other factors, which tends to cause errors in testing. Do you have any thoughts on that?
Yeah, again, good question, and it goes back to kind of what I just said, is you're testing a small portion of it. you're doing a test, you're trying to do a sampling. The hope is that your coupons that you are running or that kind of stuff is undergoing as much of the same as your production materials, and that you're actually running these products down the line. Initially, when these tests were first developed, you were actually running a much larger laminate in annealed glass, and you were cutting it and sectioning it in what we call laminate characterization, so that you were actually taking 12 by 12s from the leading edge, the middle, and the trailing edge, and doing these bakes and boil tests and other tests on them to get a good mapping of how things are. I think that over time, people got comfortable with processes and all of that other stuff, and we've moved a little bit to the coupon mode of running similar glass thicknesses down the line under the same conditions, and assuming correlation there. But you're absolutely right. You can't, again, 100% inspection, 100% testing is something that can't easily be done. So these are the next steps. It's the design of experiment and what you test that gives you the knowledge that what you're putting out is in good condition.
Okay. The next question, is there any way to confirm if the laminated glass unit used an adhesion promoter during fabrication?
There likely is. I don't think it's a visual assessment or anything like that. I think that would also be some type of destructive testing with some like gas chromatography or something like that would have to be done. I am not the best person to ask that question of, but I imagine there would be some way of detecting if there's a organosilane or something like that in there.
Okay. How much can moisture contact along an exposed edge weaken the laminate and interlayer to a point where it can delaminate?
So depending on the formulation of the interlayers, some are very hydrophilic, meaning they pick up moisture very easily and also get rid of moisture just as easily. But the effective moisture on all interlayers, they do pick up moisture. The content of, or the amount that they pick up and the rate that it picks up moisture varies. And in some cases, it's not typically just moisture that causes a delamination. It usually at the edge, it is a combination of factors. And those factors can be anything from the moisture content being absorbed to stress levels at the edge, something like the bow and warp, or I call it the kissing edge. I know that that's not the proper term, but where you have edge kink that is separating. Sometimes if you have heat strengthened and tempered glass, you have stresses like that. Also, the use of clips or anything like that on the edge can certainly thin the edges of the laminate and then exacerbate the whole situation.
All right. In ASTM C1914, why are there two different tests offered, the bake and the boil, within one standard? Because it would seem someone could decide which is easier to pass.
Well, and it's in there for a very particular reason. A lot of the products out there traditionally and historically have had absolutely no problem being dunked in a boil tank full of water. However, as products have evolved, there are surface applied materials that can give you some performance levels, but they don't necessarily survive boil. And so therefore you have the thermal portion, which is taken on by bake, and the correlation of bake and boil is pretty well known, and bake is also a very accepted test that shows the proper de-airing and durability. But the duration is what's a little different. You notice that the boil test will give you in 2 hours what it takes at least 10 to 12 hours to get in a bake test. And the reason the bake test is 16 hours is really a case of making sure that you do get that same correlation. If you put a laminate in a oven for 2 hours, it does not have the same effect as you see with the boil test. So that's why the two tests are there, but they're not exactly the same duration, so that you have the right correlation to them.
Okay, great. Another question, since the Pummel test is a relative adhesion test, what is the baseline adhesion that we're to compare results to?
So that goes back to my discussion about having the proper specification for your application. Typically, the interlayer manufacturers will give you a range, and for safety glazing, and another range for other applications, maybe a different range for blast resistance and stuff like that. Typically, the medium to high range will cover many of the applications, but a baseline, and that's the reason why there's a low, medium, and high, and not more delineation in it, is because of that, because there isn't a baseline that's good for everything. And so you really do have to understand your application and the interlayer products and what you're shooting for, no pun intended, for your application and your product. So, but in general, a medium to the high side will cover a lot of the architectural applications.
Okay. We have just two more questions and then we will
Okay.
conclude the day. Is it possible to have different readings from each side of the interlayer?
Absolutely. It is something that that's why you rate both sides. There are interlayers that are very sensitive to the glass orientation. There are interlayers that, if you think about processes, they can pick up some contaminants. If you happen to store them with something that's not compatible, you can have an adhesion on one side and a different adhesion on the other side. And that is why the Pummel test requires that you rate both sides and to make sure of what you're getting. You can also have things like coatings and inks and things like that that can cause an interference or have an altering effect on the adhesion of the interlayer to that glass surface. And you want to know those, and you can very easily see those in the Pummel test. If you have certain designs or things like that, they do come out. You can actually see them.
All right. And last question, for humid conditions, is there a recommended edge sealant or treatment for laminated glass?
Great question. It is one of those that has been back and forth for years. There have been products that have been available and then taken off the market. So the key is not necessarily is there a edge seal that will protect the inner layers. I think the bigger question tends to be, is there a edge seal that protects the inner layers and stays adhered to the glass over a long period of time? If you're looking at using a edge seal for moisture or salts and things like that to keep it out, and you're not butt glazing it or you're not doing anything like that, there are some products that are available that can do that very, very well. If you're looking at butt sealing that, then I have to refer you back to the sealant manufacturers and the what we'll call edge seal suppliers to make sure that they feel and they have the proper data that says, yes, this is going to stick to glass for the proper amount of time and at the proper levels to give you the adhesion and durability you need to keep your unit sealed up. Because the interaction with the inner layer is only one small part of selecting the proper seals and edge seals or sealants. So you have to look at all of the rationale for doing that.
Okay, very good. Well, thank you, Julie, again for sharing your time and expertise with us this afternoon.
It's my pleasure, and if there's still a bunch of you on, I do want to wish you the warmest of time and happy holidays. I hope everyone has a chance to share some time with family, friends, or even furry critters that they may have around the house, and everybody has a chance to recharge and relax. And so look forward to seeing so many of you at the next NGA event and talking through all of this or any of this that you want. So thanks, Sarah and NGA, for having me.
Thank you. Well said, Julie. Have a good afternoon.
Okay, take care.